Okay, section 1.4, angles. So this is the symbol for angles. That's when it's plural. We're just talking about one angle, I'll use that symbol. It looks like a less than sign, but it's not. It's talking about angles. Now, when I'm talking about angles, I will write out the word less than if I need it. I don't need to confuse myself with whether or not I'm talking about less than or greater than. I'm talking about angles. Okay, so there's that first down. There's some stuff over here that's considered basic. This is all definition stuff. This is stuff that you should already have highlighted somewhere with a little bit of explanation down here that I'll get to in a minute. But first, I want to talk about the real basics, the stuff that you don't have highlighted, the stuff that you really need to understand before we get to that stuff. So let's start talking about what I need a good color. Use black. What a angle really is, what it's made up of, and why we call it an angle. So an angle is formed when two rays are joined at their endpoint. It has to be at their endpoint that they are joined. So this could be ray AB, and then I also have ray AC. So these are the two rays that make up this angle. And where they are joined is called the vertex. Remember, it has to be the endpoint that they're joined at. That's why it ends up looking that way. And where they're called is called the vertex. So this particular one has a vertex of A. And that's all I have to say about it. The vertex is A. Because the vertex is A, when I'm talking about this particular angle, I could just call it angle A. And we know I'm talking about this angle because you use the vertex as its title. However, if there were other angles around it, I couldn't use angle A because we wouldn't know which angle A we were talking about. So sometimes they want you to be specific and tell them what angle you're talking about. When that's the case, you have to use 3 letters. And you kind of trace those letters around your angle to find out what order to go in. So I would start up here if I was going to trace this angle. Not here, because that's 2 different lines, and we're talking about the angle. So when I start up here to find this angle, I would get B, then A, then C. Or I could go backwards. C, then A, then B. Either way, your vertex should be the letter in the middle. That's how we understand what kind of angle we're talking about. The vertex always falls in the middle when you're using 3 letters to do it. I just thought of something. Oh, this is something that really confuses people. People think that this is the angle, that these 2 rays are the angle, but that's not really what the angle is. The angle is really the space in between these 2 rays. So when we measure an angle, we're really measuring the space in between those 2 rays because it doesn't change the fact that they are rays. You make an angle, see, an angle is formed when 2 rays are joined at their endpoints. You make an angle by joining the endpoint, but it's the space in between that's the actual angle. That's what we find a measure of. So our angle is this stuff in here. It's not these lines or rays. Okay, there's that. But wait, there's more. Okay, so more basics. We need to talk about adjacent angles. Adjacent angles have to share a ray. That's the definition of adjacent angles. They share a ray together. So This ray has to be the ray in between the two angles. It can't just be any ray. So if we're looking at these angles here, which two angles are adjacent? And it would be angle BAC and angle CAD. Those are the ones that are adjacent. Now, when I was reading this, I was like, well, what's the big deal about whether or not it's the one in between that they share? And the reason is, if they shared one of the outside ones, then that would mean that we were trying to say that angle BAD was adjacent to angle BAC. And that's not true because BAC is inside of BAD, so they can't be adjacent. Adjacent means that they're side by side. So that's why they have to share the middle one, not an outside one. Okay? Okay. Let me explain before you get upset. I went through and I read all the theorems and all of the postulates and corollaries and everything, all the definitions and everything, and I am here to shed some light on them. Now, what I'm not going to do is tell you, oh, this one comes from something else, and so, sorry, I'm getting a weird message. Give me a second. This one comes from something else. And so since it comes from something else, I'm not going to say this is really theorem, whatever. I want you to figure out which theorem it is. But I am going to go ahead and tell you that a lot of the stuff I'm telling you is a way to shortcut those postulates and theorems. This is one of those. So one of them, that's what I'm going to underline it in purple. One of them is that all right angles are congruent. That's one of your postulates and theorems. And that way you don't have to write out all the words they have there. Just find the one that is that, and then go back and put all right angles are congruent for your postulate and theorem. Because of that, they all have the same measure. That's because of the definition of congruent. So all right angles also have the same measure, which is 90 degrees. All right angles are 90 degrees. Angle bisector is technically a definition, but the definition is that it cuts an angle in half so that it forms two congruent angles. Technically, if I were to say that these two angles up here were congruent, then we could say that AC would be my angle bisector. It's ray AC, don't get me wrong, but that would be the angle bisector. But we only know that if these two things are congruent. And later on, you might get a corollary that says something like angle bisectors separated into two congruent angles. I mean, they keep giving you the same information over and over again with little bits of things different. But as long as you have one of them that's accurate on that page, we should be okay. So, try to shorten down the words that they give you sometimes so that it's less for you to write later on when you're actually doing the proofs. Now, this is something that I need you to remember from back before when we talked about congruency. So that's the symbol for congruent. So you need to remember that congruent angles, just like congruent segments have the same measure, congruent angles means that they're going to have the same measure. Now remember, the actual angle itself is the stuff in between. So we would call the angle congruent to an angle But the measure measures what it is in between, and that would have to be the same as this, because we've marked them congruent. Just like you had tick marks when they were doing segments, we have tick marks when we're doing angles. Works the exact same way. Just means that those two angles are congruent. Okay, so now we have finally gotten to the definition. So most of this I expect you to already know. We're talking about types of angles in case you can't read it well. The first one is acute, which means that it measures less than 90 degrees. I imagine you can look at any angle and tell me if it's acute or not, because I bet you've been doing that since about 3rd or 4th grade. Right angle means that it is equal to 90 degrees. An obtuse angle means that it's more than 90 degrees, but less than 180. And then we start book differentiation. What I mean is, I'm used to calling it a straight angle. Your book calls it opposite rays. Technically, it is opposite rays. Whenever you have a line with a point in there and some other points out here, those are opposite rays because they go off in opposite directions. But I call it a straight angle because I know that the angle is 180 degrees. It doesn't matter if you call it straight angle or opposite rays. It is of little importance to me. What is important to me is that you know for a fact that it's going to be 180 degrees. Every time you see a line, 180 degrees. Every single time, 180 degrees. You can even do the sound with it. 180 degrees. Just say it. Every time, it's 180 degrees. If everybody just remembered that one thing, life would be so much simpler. Okay, so like I said, definitions, pretty sure you already know. If you're afraid you're going to forget, then you need to put them on that definitions page. If you're pretty sure you already know it, then don't worry with writing it. Just be honest. Write it in the notes. Don't worry about writing it on the definitions page because you already know it. And when we get to that, you can write definition of acute angle if you need it. Okay, moving on. Let's talk about between. Your book had a definition for between in segment addition. And I said, we're just going to call it segment addition because it makes more sense. So we called it segment addition, and look at that, it made more sense. Same thing for rays. They have a definition of between for rays as well, but we're not going to call it between. We're going to call it angle addition because it makes more sense. I'm all about making more sense. So, when you have this kind of scenario, and I'm going to shortcut this a little bit. I better not. And what they would say is, since ray AB is between rays AC and ray AD, then that means that it's going to form two separate angles, and you can take the measure of angle 1, which is CAB, and add the measure of angle 2, which is BAD, and you will get the measure of the big angle, which is CAD. They call that the definition of between because it's between those two. I call it angle addition because one angle plus another angle equals that angle. I would suggest you call it angle addition. If you find that in your book as a postulate, then you need to write it down in a postulate. And it's fine with me if you just write this. If you find it in your book as a definition, then you need to take it to the definitions page and write it there. But either way, this should be the title for it because this is how we're going to shortcut it. It's angle addition, not the definition of between. It's not some angle bisector theorem. It's called angle addition. Okay. Very important information. Give me a second, please. A little bit of music. A, O, B, C, E. This is on page 20 at the bottom of the page. We need to talk about, and this is a serious conversation. I know you probably think I'm joking because I just said that, and I tend to be sarcastic, but this really is a serious conversation. We need to talk about how what you see may not actually be what it is. So it looks like, because I tried to draw it this way, it looks like AC might be a right angle. That's the symbol for a right angle. It looks like, sorry, you can't even see that. Hold on. It looks like AC might be a right angle. Could be 90 degrees. But the truth of the matter is, if they don't tell you it's a right angle, you can't assume that. We don't know if they drew it to scale or not. It looks like these two angles might be congruent, or these two angles might be congruent. But because it looks like that doesn't mean that it's like that. So you can't just assume that it's like anything. In geometry, you don't get to assume anything. Everything is either given to you or you have to prove it. That's what geometry is. There is no assumption allowed. So we can't just look at this and say that we know anything except what we do know is that there is an angle AOD. We know that inside of that angle there are other angles like angle AOB, angle BOC, angle COD, angle AOC, and angle BOD. We can tell that all of those are angles. We know that as fact. We don't know anything about the sizes of them. If they don't mark it, then you cannot assume it. It has to be marked in order for you to be able to say that that is fact. Okay, that being said, the whole point of geometry is to take things and decide what's fact based upon what they give you. So, for example, I'm going to draw a picture. This can be E. This can be F. Over here somewhere we have a G. That can keep going in both directions. Up here, I'll put it right here. I want an A, and the A connects to the F, and the A connects to the G, and then over here somewhere, I want a B, and the B connects to the E, and the B connects to the G. And where these two cross, we're going to call C, because they cross there. And where these two cross, we're going to call D. And now I'm going to start numbering some of my angles because it's easier to talk about the numbers and know what those are than it is to throw out a bunch of letters. So we're going to call this one angle 9, angle 8, angle 7, angle 6, angle 10, 12, and 11, angle 13, 14, 4, 3, 15, right here, 5, 2, and 1. I'll give you a second to draw that. Over here, we're going to put facts that we know. Just by looking at this, a fact that we know is that EFG is opposite rays or a straight angle. Which means it measures 180 degrees. Another fact that we know, ACG, opposite rays, straight angle. And BCD, I don't even have to go all the way to E, or I could say CDE, doesn't matter which one. Opposite rays, straight angle. CDE is what I'm going to call it. I call it straight angle because it's shorter than opposite rays, you're right. And that measures 180 degrees. We learned by angle addition that if that's the case, the measure of angle 9 plus the measure of angle 8 has to equal 180 degrees because they have to add up to whatever that straight line is. So this angle plus that angle has to equal 180 degrees. We know that the measure of angle 7 plus the measure of angle 6 has to equal 180 degrees because they have a straight line. So that angle plus that angle has to equal this 180 degrees down here. We know that the measure of angle 10 plus the measure of angle 12 plus the measure of angle 11 has to equal 180 degrees. Because it takes all three of them to make up this straight line. We know that the measure of angle 14 plus the measure of angle 4 has to equal 180 degrees. We know that the measure of angle 3 plus the measure of angle 4 has to equal 180 degrees. We know that the measure of angle 2 plus the measure of angle 5 has to equal 180 degrees. We know that the measure of angle 5 plus the measure of angle 15 has to equal 180 degrees. There is a ton of information we know just by looking at this. But nowhere in any of that does it say anything about congruent angles or what these measures are. All it is a picture, but just looking at that picture, we have all this information. And what you're going to need to do is to be able to look at this picture and in your head recall, oh, I know this, 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 and then say, oh, I'm going to use that one to help me get my answer. The hard part is figuring out the one you're going to have in order to help you get your answer. Because there's tons of information, and as long as you can remember some of it, because the only thing I used was that straight angles give you 180 degrees and angle addition. That's all I used to get all of this information. So if you really want to take all the time to list out all the information, you can, but it'll go a lot faster if it just kind of pops in your head. And it'll pop. It might take a little bit of time. Usually for 10th graders, it took about halfway through the semester before it would start popping for them. And you could tell the day that it happened because they would be like, oh, that's what that is. And from then on out, it was like a piece of cake for them. But until they had that oh moment, it was like really hard for them to understand where I was going with everything and how I knew stuff and how it was always simple for me and hard for them. And all it is that information pops for me. It pops right away. I think of all of this stuff when I see this picture. I don't write it all down, but I do think about it all when I see this picture. And I concentrate on the area that they ask about. So if, for example, they were to ask, if the measure of angle 7, let me back up. Make sure I was in the right spot, is 10 degrees more than the measure of angle 6, what are the two angles? Do you remember back when we did word problems, sometimes there would be extra information? Well, that's what this is. It's a whole slew of extra information. And we don't need all of this extra information. We just need the part that relates to what they're asking about. So think about this whole picture as being a whole heaping of extra information. And the only thing that they're asking about in this whole picture is this right here, angle 7 and angle 6. That's all they're talking about. Incidentally, it looks like angle 7 is smaller than angle 6, doesn't it? Yeah, but that's not what this says. This says that the measure of angle 7 is 10 degrees more than the measure of angle 6. So angle 7 must be bigger than angle 6. And that's okay, because our information that we were using is not based on which one was bigger. We didn't care that this was acute and that was obtuse in our picture. What we cared about was the information that we knew was fact. So if I just look at this picture, I could pull out the facts that only relate to angle 7 and angle 6. Now, up here, that has to do with EFG, so that's this one. And down here, that has to do with this one. Now, see, I went to all the trouble to list out everything we knew so that you could see that there's a ton of stuff that we know. But all we really needed was to know this little piece and that little piece, because that's all they wanted for this part of the problem. So, using these two facts, it says if the measure of angle 7 is 10 degrees more than the measure of angle 6, what are the two angles? So I'm going to start with this fact, because this is the one that's got the measures. They said that the measure of angle 7 is 10 more than, so that means I'm going to let my angle 6 be x, so my angle 7 must be 10 more than x, just like the code back in algebra. So down here, for where it says measure 7, I'm going to put x plus 10. Put it in parentheses so you can tell. And then where it says measure of angle 6, we said that was going to be called x. And that has to equal 180 degrees. X plus 10 plus x gives you 2x plus 10. Subtract 10 from both sides. 2x equals 170 degrees. Divide both sides by 2. And x is equal to 100, sorry, not 100. 85 degrees. I will get there. Put it in my head. Give me a break. So that tells me what x is, but is that what they asked for? They wanted to know what are the two angles. So one of them is 85 degrees. Measure of angle 6 equals 85 degrees. Measure of angle 7 is not 85, because that was 85 plus 10, so that's going to be 95 degrees. Can't go by what the picture looks like. Have to go by the facts that they tell you. But the whole hard part of it is thinking up what you need in order to solve it. So if it means you have to list out everything you know, then you list out everything you know. But you'll know, let me rephrase. You would have gone over what you need in order to do the problem. Had you seen this before we listed out everything, you'd have been like, I have no idea. But the listing out everything made it oh so simple for you to pick out, okay, that's the stuff that has to do with 7 and 6. Piece of cake simple. Now, here's the problem. Not a problem, but when we're talking about proofs, this is not what you write. You don't even get to start here. You have to say how you know that this is true. And we know that this is true by the definition of something you don't have yet. But I'd let you write angle addition. So our reasoning for this, here, I'm going to put it over here. I'm doing it in a different color though. Put it in black. Our reasoning for each of these things would have to be written down in a proof. And some of this is a piece of cake for you because you remember your properties from algebra. But getting to this point, that's the stuff that we've done recently. So your proof would have to start with something like this statement, and then definition of straight angle, which is that it measures 180 degrees, and angle addition. Both of those go into that one because I used both of them to get there. Then this one is by substitution. This one is combining like terms. Or simplifying. Then we use the subtraction property of equality. See how I kind of shortcut every single word? Who wants to write all that out? Nobody does. Okay. Then we use the division property. Of equality. And then we got our first angle. Then we took this and substituted it in back up there. But these would be our reasons for this particular problem. Now, usually when you're doing your work, I'm not going to ask for this. Unless I tell you to prove it, I'm not asking for this. But I'm telling you what it is so that you understand that we're really using the stuff that we're going over to get to this. And the stuff that we're going over is just a small part of what's all up there. And you've got to be able to recall everything that's up there. It's not easy in geometry. There's a lot to do, but you can do this. I promise you it's going to pop for you. And when it does, you'll be like, oh, this is great. Until then, it's going to happen. Okay. So I did that one, which means it's time for homework and classwork, and you're going to have fun with it. I hope you do. Classwork, page 21. Numbers 3, 17, and 21. And I do not know if those are in the back of the book yet because I hadn't gotten to there when I did this lesson plan, but just 3 problems. And then the homework, still page 21. Numbers 5, 7, 19, and 23. If you don't have the answers in the back of the book, you know you can text me and I can get them to you. Or check your work or however you want to do it, like we've been doing. But in future days, including tomorrow, I'll have the answers already prepared for you. So you won't have to worry about it. Okay. See you tomorrow. Going over the same thing. Just saying, getting ready to do it right now. I'll see you. Well, no, you'll see me tomorrow. And I don't know when I'll see you, but maybe tomorrow. Okay. Bye.